Hey everyone, Geophysicist Stefan Burns here. We just had a huge triple burst of plasma from the sun, and this is launching out directly towards the largest ever observed comet, C2014 UN271 Bernardinelli-Bernstein. This is not Earth directed, though in general when we have these sort of massive explosions on the sun, that does affect the energy of the entire solar system. But I find it quite unique that in fact during this solar maximum, during the solar cycle, we've had a lot of outbursts going directly to the south of the ecliptic plane, basically straight down. Because as we're looking at this chronograph imagery, we're looking at it just like this. So we're directly in front of the sun here, and we need this explosion to kind of go out all directions. That's like a full halo like this for it to be Earth directed. This is clearly going directly to the south. We'll look at the SUVI imagery as well to confirm that. And well, this is the largest ever observed comet. It's about 140 kilometers in diameter. It was displaying tremendous activity way out in between the orbit of Neptune and Uranus, going from 30 astronomical units to 20 astronomical units, which is very anomalously bizarre for comets. Almost no comets show activity outside the orbit of Saturn. It was showing significant outburst activity even at those vast distances away from the sun, showing that it's made up of very volatile materials that are easily ready to explode, to erupt. It's been observed to have multiple jets. It's not going to get any closer than about the orbit of Saturn. But even then, this influx of solar energy from these explosions here, these three being the most recent of quite a long list during the solar maximum, is going to continue to energize this largest ever observed comet. And what that means for our solar system, we really don't know, because there are so many dynamics at play as it relates to comets and asteroids and trans-Neptunian objects like dwarf planets and more that we just simply don't understand, we're not aware of in the first place. But that does not mean that they don't affect our solar system, the other planets, the sun, us. So in today's video, we're going to examine these solar explosions and also learn a little bit more about UN271, its closest approach to the sun, which is coming up in just about 5 years from now, and then it'll fly away and we won't see it again for about 1 million years. So this isn't a once in a lifetime transit, it's a once in a million year transit, and for a mega comet, the largest ever observed in our solar system. And here we have the SUVI imagery. For this, we see this first plasma filament launched there, but then we actually get this second one to launch afterwards, and this one was much more significant. You see that effectively going straight down to the south of the ecliptic plane, and that is where UN271 is right now at this moment in time. So we've had a lot of these extremely large prominence and filament eruptions in solar cycle 25. In fact, solar cycle 25 has been quite notable for the sheer number of solar flares that it has exploded from the sun compared to solar cycles 24, 23. Though we haven't had as much geomagnetic storming activity as some prior solar cycles like 23, 22, 21, the amount of just overall explosive activity on the sun has been very, very high. That continued yesterday. If you look back at that chronograph imagery, you'll see those three bright points of light. Those are Venus, Mars, and Mercury, all on the far side of the sun, having performed superior conjunctions. That is well connected to enhanced solar activity when we get these sort of notable planetary alignments. And I don't think it's a coincidence that we got this massive explosion of plasma from the sun as all those planets are grouped together there. Just in general, they are making the sun much more active than they otherwise would be. And one reason I'm mentioning this impact, this solar impact to this mega comet UN271 now is because when it's closest to the sun and along the ecliptic plane around 2031, it's going to be solar minimum. So right now is when we have the activity. Right now is when that energy is going to be activating this mega comet, and it could perhaps be doing a lot of jet activity more. And then yes, it'll be as closest to the sun during the early 2030s, but it'll be solar minimum. We're not going to have that extra solar impact and oomph and extra bit of jazz added into the mix. So that's happening right now, and I think it's worth noting. So let's learn more about UN271. Here we have a 3D solar system visualization tool via the Sky Live to help us see the orbit of UN271 across time. I have this set all the way back to 1906 right now. You see it slowly flying into the solar system. Here we have the orbit of Pluto, we have the orbit of Neptune. So this is the main solar system. Right now, at this time, 1906, it's in the Kuiper Belt beyond the orbit of Neptune, where a whole bunch of unusual objects, trans-Neptunian objects, dwarf planets, comets, things that we probably aren't even aware of, exist. It's flying in, and you notice that it started above the ecliptic plane, and then it starts to slice below it, and that is where it is right now. We'll go forward all the way to 2026 right here, and we'll go to the month of January, which is right now. Set this for exactly today, zoom in, and you'll see what I'm talking about. It is directly underneath the inner solar system. So it's very, very precise. This is quite notable, in my opinion, that it's directly underneath the sun, and it's not off at an angle, let's say, in between the orbit of Uranus and Neptune. It was there earlier, now it's directly underneath. So when we get these explosions from the sun that are going directly south, solar coordinate system, that is hitting the largest ever observed comet at 140 kilometers across. Here we have some information on UN271. You see the size here of, let's say, like the Rocky Mountains, right? We see the diameter of this comet. Of course, these mountains don't go up 140 kilometers, but in terms of their sheer size and mass and volume, this is probably pretty close to that. We don't exactly know the composition of this comet, so it's very likely to have a low bulk density, which is typical for comets, which is about 1 to 1.4 grams per centimeter cubed, or 1 to 1.4 kilograms per meter cubed. But in general, it could be higher because, well, the outside parts of the solar system and Kuiper Belt, there's very likely also metals and more out there. So it could have a higher bulk density, maybe has some remnant magnetization. What's the spin on that? Like, there's a whole bunch of things that we really don't know about this comet. But we've seen that's been very, very active early on, driven by carbon monoxide. So we've had these carbon monoxide jets all the way back at the orbit of Neptune and Uranus in that zone, which is where we first detected it. And we see that it has this orbit that takes it out 40,000 astronomical units or more. It's actually difficult to calculate the orbit of this sort of object because of just how long of a period it is and just how eccentric it is as well. So you start to encounter difficulties with the math, but we see that it does really go out there. And when it's out there for hundreds of thousands of years before it does this close flyby. You have to think about gravity. Out there, the gravity is quite a bit lower than it is close to the sun. So it's moving slowly, and though it's having this pool of energy, bringing it in to closer to the solar system, it's not that strong, so it can take its time. Then as it gets closer and closer, it accelerates. So it's actually like a ball rolling down a hill. It is accelerating as it's converting its gravitational potential energy into kinetic energy, and then it'll do that very fast swing around the sun, and then it has to start rolling uphill with that accumulated momentum and inertia. So right now it's in that acceleration phase. So as it can relate to the energies of this mega comet, which we don't know what they are, like the energetic signature, you could say. Every comet has a unique energetic signature, every object, every person, right? Every blade of grass, but clearly it's very unique because it's the largest ever comet observed at 140 kilometers across. I mean, that is tremendous. Most comets don't get anywhere near that size. It right now is in that acceleration phase. It's being hit by all this solar energy. So while it's not going to have its closest approach until about 2031, right now is actually a pivotal time as it relates to how this is energetically impacting our solar system. And as it relates to its orbit, when it goes out 40,000 plus astronomical units, right now it's basically as close as it's going to get. In that range, in that scale, it's right there at this moment in time, already interacting with us. I think the fact that the sun is launching all these filaments and prominence eruptions down towards this thing is a sign that it is interacting with the sun already. because you don't get solar flares typically to blast off to the south. The sunspots are clustered more around the mid-latitudes and the equatorial regions, though they start higher up during the beginning of a solar cycle and then they converge at the equator. But you don't really get sunspots because of how the magnetic field is, like pointed south and doing big solar flares south or to the north. You get them more horizontal. But these filaments and these prominent eruptions, you can have them go any which direction. We've had a tremendous amount go directly south, interacting with this thing. It has a very dark nucleus, meaning it's not reflecting all that much of this energy. Whether it's light radiation or more, it's absorbing almost everything that it receives, and it's emitting a tremendous amount of material into our solar system. It experiences these violent, spontaneous outbursts, over 100 million kilograms of material, dust, ice, whatever else, ejected in less than a day in some of these outbursts. So this thing, because it is so large, the dynamics are so much different than normal comets. A comet, let's say that's a kilometer across, and it has these outbursts and jets and leaving a dust trail. Yeah, that can be cool. It can be significant. This thing's volume is so much bigger that compared to a comet that, let's say, is a kilometer across, this is, not just hundreds, but probably thousands times more volume than that. So it has a huge ability, if it so chooses, we don't know what's going to happen, to release material into our solar system, into the orbit around Saturn. And then how Saturn, the gas giants, then start to move and shuttle and fling this stuff around, we don't know. It could easily break off a whole bunch of lesser comets. Let's say it was a fragment apart, right? Like a lot of physicists and astrophysicists and astronomers are like, oh, it's just going to go through its trajectory, it's going to swing right out. What if this thing was a fragment apart? It's been hit with all this energy and activity, and it's just been experiencing these violent, spontaneous outbursts. What if the whole thing was literally just to go? Now we can have a whole swarm of objects and mini comets and fragments and chunks flying into the solar system. And of course, if there's an explosion, their velocity vectors are going to be different. Maybe some of those get sent towards the inner solar system. Maybe Saturn gravitationally flings them closer in. Some will get flung out, of course. This is a hypothetical, but we should be thinking about these things. So when we see consistent solar activity blasting off towards this comet, I think we should be aware of that and at least be mindful of the fact that there are dynamics that exist in our solar system that are beyond our current understanding, and also all the things that we don't know. So it's good to look at this very open-minded and with a critical eye. And one last important thing to note for this comet UN271 is the fact that its orbit is so eccentric. It goes so far out into interstellar space. While it's not an interstellar object, meaning that it had this hyperbolic trajectory, this ballistic trajectory straight through the solar system, it does appear to loop around our sun. It spends a tremendous amount of time in space and only gets thermally processed by its close approach to the sun every million years or so. We actually, again, can't exactly calculate its orbital period between its closest approach because of gravitational perturbations being different from the planets. So it's kind of in that zone. Again, we really don't know. What we're starting to learn is that objects from interstellar space, they undergo different processing than objects close to a star. The cosmic environment in interstellar space is quite a bit different than it is in the heliosphere, because while the sun emits a whole bunch of plasma in its heliosphere and these solar explosions and coronal mass ejections and more, and that can thermally process objects. For example, asteroids in the asteroid belt all get thermally processed, or short period comets that fly around the sun a lot, they get heavily thermally processed by the sun. In general, cosmic radiation is much higher energy than solar radiation. So we're talking like orders of magnitude stronger at the top end of the scale. Like tremendously powerful cosmic rays, oh my god particles, gamma ray flux, all this stuff is in general a lot higher in interstellar space, which is where this spends most of its time. So it undergoes a different processing of its crust, and that would explain why it's been showing so much activity in these violent outbursts early on, as it does now enter into the energetic system of our sun in the heliosphere. Because what the research indicates is that cosmic rays and these sort of high energy plasma ions that come in from the far reaches of the galaxy and from other galaxies and beyond, they help to, in general, make things more brittle, and it kind of breaks down the structure. But this thing also at 140 kilometers has quite a bit of gravity to it compared to a normal comet. So it will still hold on to these materials and aggregates and chunks and whatever. And then if you were to get a big burst of solar energy to come in, that could cause perhaps the carbon monoxide and also carbon dioxide, water, underneath these more brittle layers that are ready to, become dust, to then volatilize quickly, causing that outburst. So as a result of these factors, it's probably more unstable than it otherwise would be. Because if it had been heavily thermally processed by our sun, then what's left is what's left. And it's not likely to do these sort of big outbursts. But because it hasn't been that thermally processed, we don't think, and because it is a mega comet, it has all this mass and everything to it, it has the ability to have these sort of dramatic outbursts and to basically litter our solar system with icy material from beyond the edge of our conventional solar system and our heliosphere and more. And what we're finding is that there's an enrichment of organics. This would be like amino acids and peptides and more from objects that spend time in interstellar space. That space environment also seems to have a unique ability to create these compounds, which are key for life. So this is a significant event, and the activation for it is happening right now during this solar maximum. We're now at the end of solar maximum, going into descending phase, but when it's as closest to the sun, it's going to be solar minimum. So we're very unlikely to see anything really launch towards it or happen with it, though it will be receiving the most light radiation from the sun at that moment in time because it'll be at its closest to the sun. But right now, in terms of solar storms hitting this thing, this is the key moment in time. So I wanted to update you all on that, because when you get a significant triple burst of plasma launching straight towards this thing, you know that something is up. And again, this is not the first time that we have seen this. So thank you all so much for watching. Again, I've been your host, Stefan Burns. If you'd like to stay up to date with what is happening here in our solar system, on Earth, everything and more, then please subscribe to the channel. I'll keep you up to date. Wishing each and every single one of you well. Please take care of yourselves. I'll see you all in the next video.